Hello guys, welcome again to my channel. Here comes a nice challenge which reads x to the power of 3x to the power of 6 is equals to 16. What is the possible value for x? So we are looking for the value of x in this challenge. So please, if you are new here, kindly subscribe, and by the time you subscribe, please don't forget to turn on the notification button so that you get notified anytime I drop videos on mathematics. So let's see how we can solve this. X to the power of 3x to the power of 6 is equals to 16. So the first thing I can do is by saying solution. Okay, now I'll write the question, which is x to the power of 3x to the power of 6 equals to 16. So next thing I can do, I can take, okay, let me multiply both sides of the equation with the natural log. So if I should do that, I'm going to have ln of x to the power of 3x to the power of 6 is equals to ln of 16. ln of 16. So since I've done this, recall if you're having ln of a to the power of a is also equals to a to the ln of a, because this will be coming to the back. So if we should put this principle here, I'm going to have this to be 3x to the power of 6 ln of x is equals to ln 16. Okay, so this is what I'm not having. I'm not having 3x to the power of 6 ln of x is equals to ln 16. So since I'm having this, what am I going to do? I'm going to divide both sides of the equation by 3. So if I should do that, I'm going to have x to the power of 6 ln x is equals to ln 16 over 3. So I've divided both sides of the equation by 3. So since I'm having this, I can, in the place of ln x, I can equate another value there. So I can say let ln x equals to a, and let x equals to exponential a. So wherever I see ln x, I'm going to put a, and wherever I see x, I'm going to put exponential a. So if I should do that, I'm having x here, so I'm going to put exponential of 6a ln, in place of ln x, right, I'm going to put a. So I'm putting a here. A is equals to ln 16 over 3. So this is what I'm not having. I'm not having exponential 6a times a is equals to ln 16 over 3. So with this, I can write again to be a exponential 6a equals to ln 16 divided by 3. Since I'm not having this, I'm not having a exponential 6 is equals to ln 16 divided by 3. Since I'm having this, I want to actually apply the Lambda-W function to solve this. One of the rules for the Lambda-W function is if I'm having a exponential a, if I take the Lambda-W function of it, it's also equals to a. A exponential a, if I should take the Lambda-W function of it, is also equals to a. But if you look at this point very well, we are having a exponential 6a. So at this juncture, we can't actually apply the Lambda-W function, because here we are having a, and at this top we are having what, 6a. So what are we going to do to make this place look similar to this? I'm going to multiply both sides of the equation again with 6. So if I should do that, I'm going to have 6 times a exponential 6a is equals to ln of 16 divided by 3 times 6. So I'll multiply both sides of the equation by 6. So since I've multiplied both sides of the equation, I'm now having 6 times a exponential 6 is equals to ln 16 divided by 3 times what? Times 6. So if I should come here to solve this, so I'm now having 6 times a exponential 6a is equals to ln 16 divided by 3 times what? Times 6, right? Okay, 3 can go into this place, we are going to have 1. 3 can go here, we are going to have 2. So we are having 6a exponential 6a is equals to 2 ln what? ln 16. So we are not having 12 because we have 2 here. So we are going to put 2 at this back. So we are having 2 ln what? ln 16. 2 ln 16. So at this point, we can apply the lambda w function because this point is equivalent to this part. Because from the lambda w function, which says if you're having a exponential a, if you take the lambda w function of it, it's also equals to a. So at this point, we can take the lambda w function. So we can say the lambda w function of 6a exponential 6a close bracket is equals to the lambda w function, because whatever we do at the left hand side, we must do at the right hand side. So we are going to have 2 ln of 16 close the bracket. So if we take the lambda w function of this, we are going to have 6a is equals to the lambda w function into 2 ln of what? Of 16, right? Okay, recall my 16 is also equals to 4 to the power of 2, right? So I can say 6a is equals to the lambda w function into 2 ln of 4 to the power of 2, close bracket. So this 2 will be coming to this back. So I will have this to be 6a is equals to lambda w function into 2 times 2 ln of what? Ln of 4, close bracket. So I'm not having this, So I can simply write this to be 6a is equals to lambda w function into 4 ln 4. Okay, so this is what I'm not having. 6a is equals to the lambda w function into 4 ln what? Ln 4. Note, you have to note something. So from here, 4 is equals to exponent of ln 4. 4 is equals to exponent of ln 4, because this exponent will cancel off this ln, so we are left with this 4. So in the place of 4, we can put ln exponent of ln 4. So we have this to be 6a is equals to the lambda w function into exponent of ln 4 times ln 4, close bracket. So we are not having this. This is what we are not having. So since we are having this, what then is the next step? I can rearrange this again to be 6a equals to the lambda w function into ln of 4 exponent of ln of 4, close bracket. So this is what I'm not having. Okay, since I'm not having 6a is equals to lambda w function into ln of 4 exponent ln of 4, and recall I said if we are having a exponential a, and if we should take the lambda w function of it, is equals to what? Is equals to a. And if we should also do the same thing for z, if we say z exponential z, we should take the lambda w function of it, it's also equals to z. So if I should put this principle here, we are having lambda w function into ln of 4 exponential ln of 4. In the place of z, we can say this is z and this is z. So we are going to have what? 6a. So we are going to have 6a is equals to ln of what? Ln of 4, right? So we are now having 6a is equals to ln of 4. So we can divide. For us to look for a, we can say a is now equals to ln of 4 divided by 6. Since we are not having this, which implies our a is equals to ln of what? Recall your 4 is also equals to 2 to the power of 2, right? So we can say 2 to the power of 2 over 6. And this 2 will be coming to the back. So we're having a is equals to 2 to the ln of 2 over 6. From the rules of logarithm, which if we're having ln of a of to the power of b is also equals to b ln of a. Okay, so this principle is what we actually applied here. So I'm now having a is equals to 2 ln of 2 divided by 6. So we are going to say 2 here 1, 2 here we are having 3. So you can say our a is equals to ln of 2 over 3. Okay, I recall we said our a is equals to ln of x, right? So we can say ln of x is equals to ln of 2 over 3. 2 over 3, right? If we do this, so we are now having ln of x is equals to ln of 2 over 3. So in order for us to look for x, we can take the exponent of both sides. So we can say, okay, exponent of ln of x is equals to exponent of ln of 2 over 3. Okay, so this is what we're now having. Exponent of ln of x is equals to exponent of ln of 2 over 3. I know exponent will cancel what? Ln. So we're having x is equals to, and this exponent will cancel also, this exponent will also cancel this ln. We're having x is equals to 2 over 3. So this is the value for x. So if you find this video useful and interesting, please click on the subscription button, turn on the notification bell. Bye for now. God bless you. Jesus loves you, and see you in my subsequent video.